Children, it's a very interesting concept. This is in current electricity. Children, now I am considering a conductor. So the name of the conductor is P and Q. Left side end is P, right side end is Q. Right? Between the ends of this conductor, an electric field is applied. A potential difference is applied. The applied potential difference is V volts. Of course, that is called electromotive force of this battery, which is a constant. The energy that is required to circulate the charge is needed. That's why we have connected a battery here, so that all the electrons are now drifted towards what? Positive electrode. The electrons are now drifting towards what? Positive electrode. So as a matter of convenience, what I am going to do here is, I consider two cross sections, cross section 1 and cross section 2. Within this conductor, I consider two cross sections. The first cross section is what? The first cross section is 1, second cross section is 1. I wanted to calculate the current that is flowing between these two cross sections. That is my aim. And I am going to establish a relationship between electric current and this drift speed. What is the speed? The speed of those electrons within the conducting material is called drift speed. That's why we have defined here, you see, the drift speed Vd is given by the speed with which the electrons are drifted in the metallic conductor. The speed with which an electron or the electrons drifted in the metallic conductor under the influence of external field. Everyone can write down the speed with which an electron gets drifted. The speed with which an electron gets drifted in the metallic conductor, under the influence of external electric field. This is an external electric field. That means we have connected a battery of constant EMF. EMF is the energy that is required to circulate a charge once around in a closed circuit. Right. So this is called drift speed. And you know the current definition. The amount of charge flowing from one end to the other end is called current. Charge starts flowing. Rate of flow of charge is established. Rate of flow of charge is nothing but charge flowing per unit time through a given cross section of the metallic wire. That is called current. Current is denoted by I. I must be is equal to Q by T. So I wanted to establish a relationship between current that is flowing from one end to the other end. The current that is flowing, and electrons are flowing from left to right. And the conventional direction of the current is always from higher potential to lower potential. Q is at higher potential and P is at lower potential. So therefore, the direction of the current will be from Q to beyond. I wanted to establish a relationship between the strength of the current that is flowing in the conductor and the drift speed of the electrons within the conductor in the presence of this external electric field. Children, please see the how to establish a relationship between the drift speed and current. Let us see here. Start from here. After writing this definition, start from here. So this is PQ is a conductor. So Q is connected to the positive of the battery. P is connected to the negative of the battery. That means Q is kept at higher potential and P is kept at lower potential. So this conductor will have plenty of free electrons. When the conductor has plenty of free electrons, all those electrons are attracted towards the positive electron. That means the electrons always flow from lower potential region to higher potential region. Therefore, the conventional direction of the current is in the direction of electric field. Conventional direction of the current and electric field direction, same, one and the same. The conventional direction of the current and the electric field direction is one and the same between the cross sections 1 and 2. So, I just wanted to consider PQ. PQ, it is a portion of metallic conductor. PQ is a portion of metallic conductor in which the electric field is applied from right to left. Electric field is applied from right to left by connecting positive electrode to right side and negative electrode to what? The left side. Very good. Let the free electrons move. These free electrons now move from cross section 1 to, this is cross section 1 and that is what, cross section 2. So from cross section 1 to cross section 2, the electrons started moving from cross section 1. This is called cross section 1. This is called cross section 1. This is called cross section 2. I just consider a specific volume between these two. I wanted to consider a specific volume between these two cross sections. So I confined the region that is between these two, what, cross sections 1 and 2. Sabash. So the direct distance traveled, now you see, let the free electrons move from cross section 1 to cross section 2. Of course, they started moving from here to here also and completely moving like this. So, but I consider the movement in between two cross sections separated by a distance L. Distance of separation between these two cross sections is what? L. Distance. So, let the free electrons move from cross section 1 to cross section 2 by the application of the electric field. Right? The distance traveled by the electrons between P and Q is what? L in time t. So the distance traveled between the cross section 1 and 2, say I just take this as 1 and 2. I take like that. So the distance traveled by the electrons between the cross section 1 and cross section 2 is what? L. This distance I have taken it as what? L in time t, right? In time t. So the distance traveled by these electrons between 1 and 2 in time t with an average speed of what? Vd, where Vd is called what? Drift speed. This is called drift speed. Drift speed or drift velocity, anything we can write. The average velocity of all those electrons is what is called? That is drift velocity. Right. Now, the distance that is travelled by these electrons between these two cross sections is equal to drift speed into time. Speed into time is equal to, or velocity into time is equal to distance. Displacement is equal to velocity into time. Distance is equal to speed into time. No problem. Distance travelled is the speed of the electron into what time taken to travel for the electron from cross section 1 to cross section 2. Fine. Now, what is the volume of this cross section? The area of cross section of this conductor is capital A. Length of this conductor is say L. Then volume of this portion between these two sections 1 and 2 is equal to what? V. Volume is equal to, you know very well, length into area of cross section. The volume of this cross section, volume of this portion is given by what? That is length into area of cross section. But what is length value? Just now we find velocity into time. The drift velocity into time into what? Area of cross section. The drift velocity into what? Time into what? Area of cross section. This is the volume. Volume. We have just considered the volume. Volume is expressed in terms of drift velocity, time of travel and area of cross section. Vd into T is nothing but length. Area of cross section is A. Length into area is volume. Okay. Fine. Till here it is fine. Now, I have to consider how many number of electrons are present for every unit volume of the conductor. See children, always remember, all of you, the number of electrons contained per unit volume. In every unit volume of this portion, every unit volume of this conductor contains, say, a few electrons. I call them N. N number of electrons is present. When N number of electrons are present in between, that is within this volume, okay. So, let the number of electrons per unit volume is equal to N. Is equal to what? N. So, the number of electrons crossing the cross section 2, the number of electrons that are crossing the cross section 2, okay, in time t is given by how much now, please step it? N into V. Number of electrons per unit volume is N. The total volume is V. So, the total number of electrons that are present within this volume is equal to N into V. Suppose 10 electrons are there, volume is 5 cc. 10 into 5, 50. N is what? Number of electrons per unit volume. Number of electrons per unit volume is 5 electrons, suppose you see. Okay. So, the volume of this portion is equal to what? 10 cc. So, how many electrons will be there? In 1 cc, 5 electrons. 10 cc, 50 electrons. 10 into 5, 50. Similarly, here n into V is the total number of electrons that are crossing this cross section. The number of electrons that are crossing this cross section in this volume is given by small n into V. So the capital N value is equals to how much now? The number of electrons that are crossing n is equals to how much? N into V. Fine. But the value of what? N into V, that is volume. This is nothing but what? Volume, not velocity. Volume. Volume already we determined here. Volume is equal to Vd into what? T into what? A. So we calculated the number of electrons that are crossing between these two cross sections 1 and 2 in a given time t is given by n into what? Capital V, n into Vd into T into A. Now we calculate the total charge of the electrons. The charge of each electron is E. So the total charge of capital N number of electrons is equals to how much? The total charge of capital number of electrons is equals to how much? Total charge of capital N is equals to what would be the value? That is equals to what? So the total charge is equals to how much? What is the charge? Total charge Q is equals to, that is total number of electrons into charge of each electron. Total number of electrons into what? Charge of each electron. The total charge of those capital N number of electrons is given by capital N into charge of each electron. So the total charge of those electrons crossing this cross section 2 in a time t, Q is equals to capital N into E. Capital N is the number of electrons in a volume V. Number of electrons per unit volume is small n. Number of electrons per that is the total volume is equals to N into V. So that is N into V is nothing but N into Vd into T into A. Therefore the total charge that is associated with these capital N number of electrons is equals to capital N into charge of each electron. That is the total charge constituted. The total charge associated with all those electrons within this volume capital V. Therefore Q is equals to capital N value we know here, N into that is Vd T into A, N into Vd into T into A into charge of electron. Excellent. Where E is charge of electron. So when you know the amount of charge that is flowing, the amount of charge flowing per unit time is called current. The amount of charge flowing per unit time is equals to what? Current. So the current value is given by what? Q by T. Rate of flow of charge is Q by T. Current is equals to what? Q by T. Okay. So then Q value is substituted here. N into Vdt, A into E by time. Time and time can be cancelled. When these two times are cancelled, so the total current flowing in the conductor is equals to N times of AE, what? Into what? Drift velocity. N is the number of electrons per unit volume. A, area of cross section of the conductor. E, charge of each electron. Vd, drift velocity. This must be equals to what? Drift velocity. So E is equal to what? Charge of electron. Charge of electron. Right? A is what? Area of cross section. Area of cross section. Cross section. Then what is? N is what? N. Number of electrons per unit volume. Number of electrons per unit volume. Per unit volume. And E, N, A, and the last one is equals to Vd. Vd is most important, that is drift velocity. The drift velocity of the electrons. Drift, speed or velocity. Drift velocity of the electrons. So this is an excellent formula. Children, please understand. This is an excellent formula. I think you understood it. So 4 steps I will tell you now. 4 steps. Only 4 steps I will tell you. I just calculated the distance travelled by these electrons between these two cross sections. The distance travelled is equal to speed into time. Excellent. What is the volume of the portion of this conductor between 1 and 2? Capital V. Capital V. So volume of this portion of conductor is equals to what? Length into area of cross section. Very good. And volume is equals to what? Length is nothing but velocity into time into area of cross section. Equation number 2. Very good. After calculating the volume, I must assume that how many number of electrons are present per every unit volume. The number of electrons per every unit volume is small n. Okay. The total number of electrons in a volume capital V is equals to what? N into V. The total number of electrons within this conductor is equals to, within this portion is equals to what? Within this portion is equals to how much? The total number of electrons within this portion, capital N, is equals to how much? Small n into what? V, volume. Small n into what? V. V value here just to calculate it, V d into T into E, drift velocity into time into area of cross section. So I am able to calculate successfully the total number of electrons that are present in this particular volume, capital V. Now, the charge of each electron is equals to how much, children? Charge of each electron is what? That is equals to E. Charge of electron 1.6 into 10 to the power of minus 19 coulombs. Correct or not? So, if it is 1.6 into 10 to the power of minus 19 coulombs, the total charge established must be equals to what? The total charge that is established by all those electrons must be equals to Q is equals to what? That is capital N into E. Capital N value just now we found, that is N into V dt A into what? Charge of each electron. Then this charge, amount of charge is found, rate of flow of charge is called Q by T. The rate of flow of charge is Q by T, so that is called strength of the current. So current is established due to the rate of flow of charge, rate at which the charge is flowing, rate at which electrons are flowing from 1 to 2, so that the current is flowing, conventional direction of current is flowing from, that is 2 to 1. So the conventional direction of the current is a scalar quantity, but it has direction. Because the current has no components, it cannot satisfy the parallelogram law of vector addition. So a quantity which has both magnitude and direction need not be a vector. Speed of light is not a vector. Velocity of light is not a vector. Electric current is not a vector. Electromotive force is not a vector. The term force is misnomer. It is not related to force. It is energy. Energy that is needed to circulate charge. That's why. So these are all have directions, but they are all said to be scalar quantities. So conventional direction of current is from right to left, second end to first end, because the electrons are drifted from left to right. Therefore, the current, strength of the current that is established is NAE times of drift velocity. This is the relation between current and drift velocity. This is one of the best questions for the current electricity portion. But in our portion, so this is also included, but it is not given in our syllabus, of course. Series, parallel, mixed grouping and everything are given, but so fine, anyway, you can just have it. Thank you.